Definition of heat. The thermodynamics definition of heat is somewhat different from the everyday understanding of the word. It is essential to understand clearly the definition of heat given here because it plays a part in many thermodynamics problems. If a block of hot copper consider a water, cold water, and a block of copper. Hot copper. We know from experience that the block of copper cools down and the water warms up until the copper and water reach the same temperature. In the next state we have equality between T and also copper have the temperature T, and water reach the same temperature. What could cause this decrease in the temperature of copper and the increase of the temperature of water? This is the question. We say that it is the result of transfer of energy from the temperature equality is due to energy transfer from copper to the cold water. It is for such a transfer of energy that we arrive at the definition of heat. It is from such a transfer energy at the definition of heat. So we can write heat is defined as the form of energy that is transferred across the boundaries across the boundaries of a system at a given temperature to another system at a lower temperature. By virtue of the temperature difference. That is, heat is transferred from the system at the higher temperature to the system at the lower temperature, and the heat transfer occurs solely because of the temperature difference between the two systems. Another aspect of this definition of heat is that a body never contains heat. Rather, heat can be identified only as it crosses the boundaries. So we have note here the bodies never contain heat, they contain energy. And the second note is the heat can be identified only when crosses the boundary. System boundary and if we consider the hot plug of copper as one system and the cold water is the beaker as another system, such as previous example, we have ice and copper, for example. We recognize that originally neither system contained any heat. They do contain energy, of course, as we said before. Then the copper plug is placed in the water and the two are in thermal communication. Heat transfers from the copper to the water. Heat until the equilibrium of temperature is heat transfer until temperature equilibrium is established. At this point, we no longer have heat transfer because there is no temperature difference. Neither system contains heat at the conclusion of the process. It also follows that heat is identified at the boundary of the system, for heat is defined as energy transferred across the boundary. It is defined as energy transfer across the boundary. Heat, like work, is a form of energy. So the unit of the heat and for any other form of energy as well as are the same as the unit for work, or at least are directly proportional to them. In the International SI system, the unit for heat is joule. In the English system, the foot pound force is the appropriate unit. US customary or English system, foot pound force for heat. However, another unit came to be used naturally over the years, the result of and associated with the process of heating water, such as that used in connection with the definitive heat in the previous section. Consider a system of pound mass of water at Fahrenheit. Let a block of hard copper of appropriate mass and temperature be placed in water so that the thermal equilibrium is established. The temperature of water is it means of a hot copper. The thermal temperature equality at or we can say thermal equilibrium. At this unit, amount of heat transferred from the copper to the water is posited is called the British thermal unit. So the amount of heat British thermal unit BTU or specified is called also 60° BTU. Defined as the amount of heat required to raise 1 pound mass of water from the 59.5 Fahrenheit to the 60.5 Fahrenheit. The BTU as used today is actually defined in terms of the standard SI unit that involves nothing there that a unit of heat in metric also. The calorie amount of heat to raise 1 gram of water from 14.5 degrees centigrade to 15.5 degrees centigrade is calorie. Heat transfer to a system. Heat transfer to a system is considered positive. And heat transfers from a system is considered negative. Thus, positive heat represents energy transfer to system. And negative energy leaves the system. Energy the symbol Q represents heat in thermodynamics. A process that there is no heat transfer adiabatic process. From a mathematical perspective, heat like work is a path function. And is recognized as an inexact differential. Recognized as an inexact differential, that is the amount of heat transferred when a system undergoes a change from state 1 to state 2 depends on the path that the system follows during the change of state. Since heat is an inexact differential, the differential is written as delta Q, and the integration is expressed as Q from 1 to point 2. In words, Q from 1 to point 2 is the heat transfer during the given process between state 1 and state 2. The rate at which heat is transferred to a system is designated by the Q dot delta Q on dt, and the specific heat denoted by Q expressed as this relation. Heat transfer mode in the next part.